Thanks to everyone who's joined us today. It's my great pleasure to welcome Anind today, who is the Dean of the University of Washington's iSchool. And he is our second speaker at UChicago CS and our distinguished lecturer in HCI series. So I'm particularly thrilled because the last time I asked Anind to participate in a speaker series, he was in the middle of a cross-country move because he moved from Carnegie Mellon University, where he was also a professor and the director there of the Human-Computer Interaction Institute. I could go through the rest of his accolades and all the other places that he's worked at, but that would take up the whole seminar. But I will say that Anind is famous for his work in context-aware computing, where basically he helped us understand how to teach computational processes to recognize the context they're in and how to respond to those contexts. And today he's going to speak to us about how he's applied those approaches to the health context. So without further ado, I'd like to turn it over to Anind. Take it away, Anind.
Thanks, Marshani. Thank you all for joining today. I wish I could be with you in Chicago giving this talk. I was really looking forward to it, but hopefully there'll be a time in the not too distant future where I'll be able to do that. So today I wanted to talk to you about some work that my research group has been doing in trying to leverage and understand people's behavioral routines to try and understand their health conditions. And so when I talk about routines, what am I talking about? I'm really talking about, you can look at this comic on the screen, the set of things that we do over a period of time. So in this case, it's over a course of a day. Someone gets up, they go to the bathroom, they take a shower, they go downstairs, have some breakfast, and then carry on through the rest of their day. And so routines have activities that we perform, members. They occur in a particular sequence, but that sequence can be out of order. I might, have breakfast once I get to school rather than having breakfast before I leave for school. The activities can last a sort of ideal duration or have a regular duration, but then that may change in different times. And I think the thing that for me that's most exciting about routines is seeing how can we leverage the routines as a computational resource for understanding more about people and in particular their health conditions. Some past work we've done easily a good 15 years ago was really successful at showing how deviations to a family's routine are actually really stressful for parents of young kids. You wake up in the morning or you wake up in the middle of the night to a child that's sick, how that causes stress throughout the day because it causes sort of a cascading set of deviations. Well, when we suffer deviations or when we deal with deviations, there are both deviations that are planned, like me giving this talk is a planned deviation from a regular schedule, versus an anomalous deviation, something that I'm not expecting. And each one of these routines and deviations, whether they're small or large, regular or anomalous, are really critical for understanding people's different situation, and particularly what I care about is their health situation. There was this really great book, and since then a web visualization that was produced about 3 or 4 years ago called The Daily Routines of Famous Creative People. And it was really kind of inspiring to me to think about, well, how can you characterize the routines of different people? So the author, the editor who aggregated all this data went back to look at old texts and old diaries that they found for these various famous people from different walks of life, to get an understanding of how they spent their time. And to me, it was just really fascinating to look at, the patterns that people had in their lives, those that took naps in the middle of the day or early in the day, because that was a nap from 8 to 9 a.m. De Balzac took a nap from 8 to 9. Mozart napped from 3 to 4. Again, these were sort of routines that were generated out of historical documents that were found. But really looking at, well, if you can start to characterize, not at this gross or coarse level of routines, but if you can start to characterize people's routines at a really fine-grained level, what can it tell you about the individual? What can it tell you about their lives? And what can it tell you about how you might be able to improve or adjust what they're doing? So then how do we actually start to collect these routines? Well, we need to start thinking about all of the things that you interact with every day to think about how could we construct knowledge of your routines? Because here we're looking at sleep, creative work, your day job, whatever that happened to be, food and leisure, exercise, and then broadly categorized other activities. So those are fairly coarse-grained, but if we want to get fine-grained information, we need to think about all of the objects that you interact with on a regular basis. So to me, this is fundamentally an HCI problem. This is a question of understanding what people are doing and how they're doing it, and really why they're performing different activities and interacting with different objects. It's a sensing problem, so we need to be able to sense these interactions with the devices around us and objects around us. Those objects have to be imbued with some kind of intelligence to be able to understand what interaction is happening, and the ability to communicate that out, which is not a far cry from many of the smart devices a lot of us have in our homes these days. But they're still relegated to my smart refrigerator or my smart speaker or my smart whatever, as opposed to everything being imbued with this ability. And then the data science and machine learning comes in to really try and extract and learn these routines and their deviations over time. So there was another art project that came out a couple of years ago, about 5 years ago, that it was called A Day in the Life of. And they did was they recruited individuals to take a picture of all of the artifacts that they interacted with in a single day. So what you're seeing on the screen here, I don't know if you can read it at the bottom there, but it says, A Day in the Life of Lauren Spencer King, artist and meditation teacher, 34 years old, there's a typo there, Los Angeles, March 29th, 2015. The book was called Everything We Touch. And here you can see, she's got her clothes over here. She's got some of this stuff I don't even know what it is. She's got the newspaper, she's got her laptop, she's got her phones, shoes, keys. But if you look at here, what you notice is that, and maybe not as surprising for someone who's an artist, but the amount of technology that this person's interacting with is pretty limited. It's pretty limited to just these two devices here, the computer and the phone. Most of what we see over here, there's no computational enhancement. Let's take another look at another example. This one, the text did not come out on the bottom, but this is for a chef in Marrakesh. I don't remember how old this gentleman is, but a chef in Marrakesh, and not surprisingly, all of the middle of the screen is stuff that he uses for food. He gets around on his scooter. Bottom, mostly it's all food stuff. You see a phone in the top left, but really not a lot in the way that's technological in it from any standpoint from which we would normally be able to gather routine information. So there are some significant challenges on how do you even collect information about what people are doing every day when you're limited to people's ability to just interact, or our ability to sense interactions with only the computational aspects of their lives. So why are routines important? I went into this a little bit, but we develop routines. I mean, this comes from years and years of cognitive science literature, really showing that we develop routines as humans to reduce our cognitive effort. The less I have to think about what it is I'm going to do when I wake up in the morning means I can put my attention somewhere else. I don't actively think about the activity of brushing my teeth. It's just something I do. I start it, and before I know it, it's over, but because I've been able to think about other things. When I have a deviation or anomaly, I now have to re-exert that cognitive effort, and that causes that extra stress. Particularly if I go out, again, not these days, but pre-COVID, when I would go out of town, which I did fairly regularly, all the things that I was responsible for in my household, I now had to share that with my wife. Whereas before, I never even consciously thought about those activities once they became a routine. Where was my daughter's bow for her viola? I know the 3 places that she leaves it in the house, but my wife, to even try and convey that information when I didn't even really recognize that I had that information, was really stressful for me, but it was also stressful for her because she didn't have the information she needed to get our daughter to orchestra practice when I went out of town. I think that routines are really actionable, as I said before, from a computational standpoint. They tend to be, they can be really long-term. They can be built into our behavior. So that tells us a lot about individuals that we're working with. Routines can be an opportunity for change, because if you can show someone that they have a negative or perceived negative behavior over a particular length of time, then by making their routines transparent to them, they can say, oh yeah, I see that there's an opportunity for change here. They can also be a barrier for change. The longer lived, the longer worked in a routine is, the harder it is to make a change to that. So it's also useful to understand the sort of our likelihood of being able to have success in making a change, assuming that behavior change is what you're aiming for. So there are really a lot of opportunities here. From a software perspective, our challenge over the past few years that we've been working on is how do we extract these routines and how do we develop a measure of routineness? How routine is somebody's day to day? How routine are we predicting someone's day is going to be? How do you quantify that or calculate it? So I want to talk about, I'll go through just a handful of projects today just to give you a flavor of some of the things that we've been working on. This project's a little bit old. It was done by one of my PhD students at Carnegie Mellon, but kind of set us off on this path of really studying routines. So this project was looking at activities of daily living and senior mental health, in particular seniors who were at risk for mild cognitive impairment, but who had no diagnosis of it. But they were at risk of it because of either family history or because of comorbidities that they had. So on the screen here, you can see a bunch of different activities that someone who wants to live independently should be able to do: manage their medicine, communicate with the outside world, balance their finances, make a meal. Pretty standard things that many of us are able to take for granted, but when you start having cognitive impairments, it impairs our ability to perform some of these activities. So Matt, my PhD student, Matthew Lee, had looked at a bunch of these different activities of daily living and said, which are the ones that we could sense reliably, given, neither of us come from an electrical engineering background, neither of us had the skill set to build complex technology or new sensing technology. What could we build that was pretty simple that could try and get access to some of these activities that were worth studying? So Matt built a pillbox. He built something that interacted with the individual's phone, and then he built a coffee maker. So we gave participants a pillbox, which from the front side basically looked like a regular day of the week pillbox. You can see a small sensor in black right there. But for the most part, most of the technology was on a second pillbox that was just super glued to the back. So it was kind of you had a pillbox that was double the size, but for the most part looked like your regular day of the week pillbox. Phone, we didn't have to interfere with anybody's phone. We were able to just add a phone sensor in line with the phone connection, a physical hardwired phone connection, which was fine for most of our elders that we worked with because they were not using mobile phones. And then we gave all of the people in our study a coffee maker. And for each one of these, what we were looking at, so for the pillbox, we were looking at simple things like, do they know what day of the week it is? So how, just knowing what days of their opening is important. When they open the pillbox, are they struggling to open the pillbox? Because sometimes they can be a little bit tough or rigid. And so are they struggling? Because we can monitor that. Did they flip open over the pillbox? Did they stick their finger in and pull them out? Did they leave any pills in for that day of the week? So it gave us access to a lot of that kind of information, fairly fine-grained detail. And what we were really interested in looking at were a couple of things. Where did they make mistakes? And primarily, where were they making mistakes that they recovered from? So if you think about someone who's undergoing cognitive decline, even in the pre-decline stage, and I see this with my own parents, or I saw this with my own parents, that, if I go and look at their pillbox at the end of the day, I can see that they've taken today's Monday. I can see that they've taken their Monday medicine. But what I can't see is, did they get confused about what day of the week it is? Did they take all the pills? Did they take some of the pills and later in the day took, maybe in half an hour later realized they forgot one of them, so they go back in and get the other one? I can't see the mistakes they make on the way to a successful completion. And it turns out that as you're suffering from cognitive decline, as you start to decline, you start to make these mistakes that you recover from long before you make the mistakes that you don't recover from, which are, I completely forgot to take my medicine. So hopefully that makes sense. Around phone calls, we were looking mostly at missed dials. How often do you dial the same number? Like, because you missed dial. How many times do you dial that number before you get it correct? And the coffee making task, it's a fairly simple task. I don't drink coffee and I don't know how to use a coffee maker, but it's a fairly simple task where you can do the steps in different orders. You don't have to do everything in a prescribed order. And so we were looking at that order and seeing whether people were making mistakes. So this is a quick snapshot of a typical deployment. You had a laptop in the background that was just collecting everything that this person hid behind their TV. And then their pillbox was here. And this person was a crafter, had lots of craft supplies. And that's what you can see all over her space. So mostly our technology blended in, although I will fully admit that it was pretty cumbersome and pretty large and invasive. What did we provide in their space? We provided them a tablet display that showed them what happened the previous day. So this would be, today's Monday, so this would show them what happened on Sunday. So on Monday morning, they would get to see. On Sunday, in this case, let me take Wednesday. So pretend today's Wednesday. They would get to see that what happened on Tuesday. So Wednesday morning, this would get populated with Tuesday's information. And here they can see that they opened Sunday and Monday, and then they correctly opened Tuesday and took their morning medicine at 6:20. This shows that they forgot to take their afternoon medicine or their evening medicine. And so we gave them little scores on how timely they were with taking their medicine and how correct they were. This visualization just shows how many phone calls they made on Tuesday and how many missed dials. They had 2 missed dials. And then on the bottom, it shows the tasks that they successfully completed to making the coffee in the morning or whenever they made coffee. And in this case, it shows that they repeated one of the steps. So pretty simple information that was presented back to them. But what was interesting is revealing just one day of data allowed them to see patterns of data. Allowed them to see, understand or take in their routines over time, and that understanding how their routines over time were not where they wanted them to be. They started making changes to their behavior without us asking them to make any changes. So what you can see here, these graphs, I apologize, a little bit complicated. On the top, you see a graph of participant 1, and on the bottom, you see a graph of participant 2. And what you see along the horizontal axis are months of the year. So this started in July and goes out to February, and each vertical line represents a day, starting at 12 a.m. and working down to 4 a.m. So you can see from here to here is a vertical day. So what you're seeing here, this top grouping of data is really the morning medicine. And what you're seeing here is the evening medicine. And for this person, they only had the morning medicine. So you're seeing the cluster between 6 a.m. and 10 or 11 a.m. So we deployed our technology where we did not put the display in place. It was just the sensing technology. We deployed that for about 2 months, July to September. And you can see that for the morning medicine, a green dot means they took their pill on time within some variance. And then yellow meant that they forgot that they took the medicine late, and red meant that they just forgot their medicine completely. And so you can see for the morning medicine, it was quite a bit of variation. Some mistakes were getting made, but very few where they were completely unsuccessful. 1, 2, 3, 4, 5, 6, 7. Roughly, the granularity is not great here, but about 7 times they forgot to take their morning medicine. Here, this evening medicine, you can see 1 mistake happen, but in general, they were pretty good and pretty regimented about their evening pills. For this individual, you can see that there were many, many more mistakes, but mostly that they successfully recovered from where they took the medicine late, as opposed to forgetting the medicine. Then in October, we put the display into their space so they could start seeing what did they do just the previous day. They didn't get any historical information other than what happened in the previous 24 hours. And you can see just having that data where they could see, oh, I made a mistake that had a huge impact. Sorry, I should say 2 things. We showed them all of the data that we had collected from them before. And then when we gave them the display, they were only able to see the previous 24 hours. So the combination of showing them their early routine data plus the daily data that they were receiving helped provide a lot of regularity to the medicine taking, as well as reduce the number of mistakes. And even for this participant 2, who had a lot of failures, and a lot of unsuccessful medicine taking, you see that there's no red dots, or early couple of red dots, but no missing, and many fewer late taking of medicine. So clearly, having this displaying these routine information can have an impact on this behavior. And we did the same thing around the other 2, making phone calls and making coffee, and we saw similar kinds of improvements in behavior change. Interesting thing is once we took the display away, those behavior changes lasted for about 3 weeks, almost uniformly across our participants. And then behavior sort of reverted back to what they had without the display. So the display is having some kind of reminding effect, even beyond showing them the initial 2 months or 3 months of data. So one of the interesting things that we found is that all the way throughout this deployment, this 6 to 7 month deployment, we also had occupational therapists come in and deliver what's called a mini mental state examination, which is basically a test of cognitive ability. And what we found is that the routines and the mistakes that people were making across these 3 different tasks were very, very highly correlated with their scoring on the mini mental state examination, enough so that we feel comfortable in saying that we can use these in place of the examinations because they correlate so well. So that really saves the time of an occupational therapist, because if you can get access to this kind of information, it will make it much simpler for you to decide who you need to go out to visit physically in person versus who do you just need to look at some of this data. So we get these regular repeated time assessments that at least occupational therapists found valuable. Clinicians found this clinicians, sort of traditional primary caregivers, found this only valuable to a certain degree because they weren't really sure what the clinical meaning of this were. When we worked with gerontologists and occupational therapists, they much more quickly saw the value of this information. So I think there's still some work to be done to help translate this directly to the medical community. Another example I want to give before I move off this particular example is one individual that participated in our study who you can see did pretty well, wasn't really making any mistakes, and was fairly healthy up through November. So he was doing well. In January, he had a bad fall. He was hospitalized and he passed away. What's interesting, because because part of our protocol was not to monitor this in real time, and that was very specifically required by our IRB, is that we wouldn't be responsible for the data because we weren't allowed to monitor the data in real time, is had somebody in the clinical world being monitoring this, you could start to see lots of mistakes, like significant areas where medicine was just not being taken, all of these red dots. And I'm not saying that because the person stopped taking their medicine, that's the reason that they had their fall, but there's clearly some change that happened between November and December where that was impacting this individual's behavior and their ability to take their medicine reliably. That gives me hope that with either an automated system or a clinician being able to monitor this kind of routine information, there's real promise for having an impact on people's lives. In the interest of time, I'm going to skip this driving one and just sort of jump to another health one. So, we did a bunch of work in working with elder senior citizens, and then we started looking a lot at student health. There was this great article in the New York Times, it's Sunday Magazine, now several years back, where it had a picture of backpacks on a campus, and it showed the backpack was to represent each student who had committed suicide that year on a college campus. And I don't think I really realized how challenging our students had it with respect to mental health before reading that article, despite being in academia most of my adult life. I just didn't have an awareness of the challenges that our students face. And so I started thinking about, are there opportunities for us to use routine information to tackle issues of student health? So the first example I wanted to walk you through very quickly is in the area of substance abuse. And in this case, binge drinking. So 41% of young adults abuse alcohol. That does not mean that they're alcoholics, but it does mean that they drink to excess. There's lots of high rates of alcohol morbidities and comorbidities. There are lots of evidence to show that current interventions are not successful at changing these hazardous use rates, these binge drinking episodes. And so I was approached by a clinician at the University of Pittsburgh Medical Center who said, hey, I've seen some of your work and routines. Do you think you could help us determine when a college student is binge drinking? And my initial reaction was, no, I don't think we can. I was thinking, most of our work is, I can instrument people's environment, but a lot of this drinking happens at bars or in dormitory rooms or in fraternity or sorority houses on college campuses. A lot of our instrumentation is on mobile phones and on wearable devices that you might have on your wrist. And I just didn't see a way that we could collect it. But he said, give it a try. See if this is an interesting problem to you. And, we spent some time at a bar watching, me and my students watching people drink. And you do notice changes in people's behavior. Some people didn't touch their phone. When they started drinking significantly, their phone stayed on the table and there was no interaction with it. So you did see that change in behavior. Others, if they got up to move around or as they were gesturing, their natural inhibitions were expressed and their ability to walk straight lines were impacted. But those were really when they were really heavily drinking. And so I told this colleague at UPMC, Brian Suffoletto, who is an expert in text messaging intervention around binge drinking. I said, I think there's something promising here that we might be able to, I didn't want to make any promises, that we might be able to work on. Let's go ahead and start collecting some data. So we collected some data, pretty modest population, about 38 participants. And what you can see in Gray are the number of non-drinking episodes that people reported. Orange are the binge drinking or heavy drinking episodes, which, just for clarification, heavy drinking is considered, it's based on body mass index, but traditionally we think about it as more than 3 drinks for a woman and more than 4 drinks for a man. But it really is body mass index dependent. So you can see in blue the regular drinking, so less than 4 or less than 5 drinks for a man or a woman, and the orange, which are greater than those numbers. And so you can see across our 38 participants, we had a fair number of binge drinking episodes. I don't know if you can see some where there are no drinking and only heavy drinking or binge drinking episodes. I don't know if that was report bias in our subjects or whether there were some students that when they drink, they only drink to excess, which, is certainly possible and plausible. There's a pretty strong prior in terms of being able to detect when a college student is drinking. A lot of it's happening on the weekend. So you can see a lot of the heavy drinking episodes are happening scattered throughout the week, but that sort of hit their peak on Friday, Saturday, Sunday, and they happen between particular hours. I won't say when you think it starts, but it's pretty high around 9 p.m. and continues to be pretty high till about 2 a.m. So there's already a pretty strong prior if you use day of week and time of day. And that's primarily what our text messaging colleague was working with, just sending messages saying, hey, if you're going to be thinking about drinking today, here's things that you should think about to control your drinking episodes. So we collected data from mobile phones and from Fitbit devices, and we were able to identify a number of features. Some of it was, while we did not look at text message content, we did look at Right, that's not fair to say. We didn't look at the words people were typing, but we looked at use of emojis, but we didn't look at any content, other kinds of semantic content that people were typing in their text messages. So it turns out the number of emojis you use changes depending on how much you drink, not you as an individual, but our study population. How people move, that's not too surprising. Whether people move, so some people, like I said, will move a lot. Some people will stop moving completely as they move into a binge drinking phase. But there were a number of signals based on the number of phone calls that they were making, who they were making them to, all of these things that we can sense from a mobile phone, the accelerometer, whether the screen was being turned on, how often it was being turned on, how long were active sessions with the mobile phone, as well as some really simple information we could get from a simple Fitbit, which could look at steps and things like that. So with this, we were able to produce this measure of being able to detect in pseudo real time within 30 minutes that someone was in the midst of a drinking, non-drinking, or heavy drinking episode. So you can see that we're pretty good on the heavy drinking. Obviously, not the hardest thing to do, be able to detect non-drinking. Where we still have a lot of room to grow is in the detecting the drinking episodes. Our goal was to optimize a system that could could detect heavy drinking episodes, because those are the cases where, a student may be so inebriated that they may be making really poor choices, either in what they may do to another person or what somebody else might do to them. And so those were the ones that we were primarily optimizing for. We had built different models that did better on the drinking, but did worse on the heavy drinking, and true positives on the heavy drinking. So, there's lots of ways to spin this kind of data. But I think this is the most accurate way of representing it, because this gave us sort of our best metric for our best measure of detecting heavy drinking episodes. So our latest work is looking at prediction. Can we identify signals in people's behaviors that allow us to predict in advance that they're going to binge drink? Now, this isn't very far in advance. Our clinicians said, could you predict 24 hours in advance? And yeah, our recognition, our prediction ability is pretty much useless 24 hours in advance. And even now, while we're still optimizing this, we're not bad at predicting 1 hour ahead. So with about 85% accuracy, looking at the last 6 hours of data. So it's like here in Seattle, it's 1:30. Let me make it 2 o'clock. So at 2 o'clock, we would be making a prediction of whether the college student would be drinking at 3 o'clock, and we'd be looking at data for the 6 hours before 2 p.m. So by looking at this data, we were able to produce a model that could predict, again, whether a college student was going to binge drink with about 85% accuracy. This holds a lot of promise because there's lots of opportunities to do much better interventions. This is where the clinicians are experts in being able to deliver these preemptive interventions to stop behavior. So on that note, this work is now being integrated into a 5,000-person intervention trial, which we're really excited about, one arm within that trial. We've since launched some work looking at the cognitive effects of marijuana, taking a very, very similar approach. And we're just starting on some work looking at opioid cravings based on our ability to detect this use of various substances. A second project that I will spend just a tiny bit of time focused on is looking at a different aspect of student health. And this is really looking at mental health issues. So these statistics on the left shouldn't be surprised. And as we are facing these pandemic times, I expect all of these numbers to just get worse because of the lack of interaction that we are having with our students, but also that students are having with each other. And the rest of the world. And so these things result in lower academic performance, twice the likelihood of dropping out as a result of high levels of depression, and an increase of suicidality. And so the things that we're really interested in looking at are how lonely are people and whether you can detect signals of loneliness through, again, the smart devices, the objects around them, that they interact with on a daily basis, the ones that we're actually able to detect those interactions with. So around loneliness, depression, sleep, and sleep quality, rather than obviously, because you can get wearables that tell you about how well somebody's sleeping, but how well can you intervene in people's sleep and sleep quality and improving that. And so I'll cut to the chase before I talk about some of the techniques we're using, but we're about 88% accurate at detecting, and I want to be very careful here about what it is we're detecting. For a college student, we have data that we've collected for an entire academic term. We now have 3 years of data from Carnegie Mellon, and this year we're collecting our 4th year of data at University of Washington. So we have about 7 years of data, although some of those years overlap, and some of the students are the same, and some of the students are different because 2 different universities. Within an academic term, by collecting data over the entire academic term, what we can show is that with data from the first half of and really the first 3 weeks of an academic term, we can be about 88%, higher than 80% accurate at predicting whether the student will exhibit a high number of depressive symptoms by the end of the academic term. I said that totally wrong. What I meant was a second number. That's the prediction number, the 75%. So we're 75% accurate at being able to predict someone's end of term depression level using data from the first couple of weeks of the quarters here at University of Washington, semesters at Carnegie Mellon, where we have part of our data from. On the detection front standpoint, which again I will argue detection is not as valuable, although it's still valuable, not as valuable as prediction, we're 88% able to detect depression levels. And so you've got all the data for the entire term and you're making an assessment without requiring the student to fill out manually an assessment or to go see a clinician to get assessed. So it's good. It's not good enough for real clinical practice, but it's still certainly very promising in what we're able to do. And we have similar numbers for loneliness and for some of our work in sleep intervention as well. So I don't have a lot of time left because I do want to make it open up for questions, but I want to talk a little bit about some of the techniques where we're looking at, where we're trying to innovate in terms of our abilities to identify what should go into these routines. So we've been looking a lot at what we're calling contextually filtered features. So as I described with, a really good feature for detecting depression is your location entropy. How much time you spend in how many different locations. So the greater your entropy, the less time you spend in a greater number of locations is really well correlated with low levels of depression. The more time you spend in 1 or 2 locations, and if you only visit 1 or 2 locations and you spend all your time there, that's a pretty good signal that you're depressed. And obviously COVID times, I would argue that we need a different model for detecting depression because a lot of us are spending a lot of time at home right now. But when we have freedom of choice and freedom of ability to move around, that's a really good signal. But that doesn't mean that where you are and how much time you're spending there and the activities you're doing in those places are always relevant 24 hours a day, because when you're asleep, that kind of data is not relevant, right? So what if we could identify features that were truth that you could collect all throughout the day, but that were only relevant in specific context? So here we're looking at sleep duration, but we found that sleep duration might only really be valuable on a day when you've had high activity levels and you spent a significant amount of time off campus. That's when sleep duration is a really important feature. So by using these really sort of more specific features, we can hone in better to the signals that are most relevant to the outcome that we care about. So traditional pipeline that we would use was, we'd collect all of our data, in this case, we use association rule mining. We'd split it from a test set and a training set. We'd mine that data. We'd go build rules based off that. Instead, what we've been looking at is, can we identify these contextually filtered features, identify which are the ones that are most correlated with our outcome, in this case, depression, identify those for two different groups, the depressed group and the non-depressed group, historically looking back at the data, and then mine rules for those two groups independently, and then look for rules that are the same within the group and that differ greatly across the group, right? Because those help identify your group at the top or bottom more closely, and also help you distinguish those from those two groups. So I won't bore you with the details here, but what this shows is that, and really the yellow and the pink lines are the ones to look at from an accuracy standpoint. If we just use the simple non-contextually based features, we could get to an accuracy about 72, 73%. But with the contextually filtered features, we can now rise about 80%. So there is some value in adding these signals that are not always useful, but that have times or moments when they're really, really valuable. And so using them in those moments and not sort of generically allows that signal, the signal that they represent, to come out a little bit better. Also, our approach, because we really care about being able to understand and make these rules transparent, going with an association rule mining approach allows those rules to be interpretable, so that's really great. One of the challenges we're having, though, is in seeing whether those rules that we are able to generate from one cohort can then be applied to another cohort. So can we take the models we created at CMU and then apply them to our UW data? Or can we take 1 year of UW data and apply it to the next year of UW data? And what we're finding is that the rules themselves are not transferring very well, but that the whole pipeline transfers well. So that's good to some degree, but our next step is to look and see whether we can get rules and models that will generalize from cohort to cohort, because that's where you can get the big win so you wouldn't have to collect data all over again and retrain, because that's obviously quite painful. So coming to the end here, our goal has really been to build interpretable and really accurate models of routines in general. And we're still working, I think it's my holy grail. I don't know if I'll ever get to it, but to come up with a really strong mathematical model of what it means to be routine and to have this measure of routineness. Our work is still going to focus on mental health and substance abuse. That's where a lot of our clinical partners are interested in. But the problem that's been motivating me for a while is I really wanted to build an interactive decision support system. So earlier when I was meeting with some faculty, someone asked me, a new faculty member asked me about what role should technology play in helping us, address issues of health, whether the answer should be technology or whether technology should play a role up to a point. And honestly, I was thinking about this point on this slide when I was answering that question. I don't know the answer to that question. But one of the things I would like to build is very technology focused. I would like to build a decision support system that allows a college student to say, this is the outcome I'd like to have. I'd like to be socially engaged when I'm in college. I want to get good grades. So I can sort of describe my optimization function, and then ask questions about what I should do to achieve that. Should I go to this party, or should I stay home and study and then cram the next day? A system that would allow an individual to make better choices, more informed choices, based both on their own routines and behaviors, but also routines and behaviors of people that may be like them. And so we're working on that with our depression group in particular right now, but it's very, very early stages. I think there's a lot of opportunities to innovate by using everyday objects. I said before, we use mostly smartphones and smartwatches that you can carry, and maybe smart speakers in your environment. But because most of the objects we have around us are not computationally enhanced. But I think there's a lot of opportunities for those objects to be a resource for design and for computation. The challenges are still figuring out what exactly is we want to sense, how to sense it, how to create well-curated data sets, particularly getting ground truth, and then being able to extract routines. And to produce systems that hopefully one day, they don't yet, but hopefully systems that will have some significant societal impact. So just a reminder here of these are the many things that you might be touching in your daily, in part of your daily routine, and to think really carefully about how knowledge of your own routine might be impacting your behaviors, and how changing your routine, either purposefully or for some anomalous reason, could actually help improve the routines that you have, and the role of computation in helping you understand that. So I will end there, and I'm happy to move to questions.
Thank you so much, Anand, for that great talk. So we'll now take questions on the YouTube chat as well as the YouTube live stream. If you have a question, feel free to indicate if you're a student or faculty member. I'd be happy to convey that. And while we're waiting for the first few questions to stream in, I guess I will ask a question, which is, I was wondering, with all the student data that you're collecting, and even from the older adults, what are the privacy and security issues with this? So how did what did these students exactly consent into? And when you're saying, oh, we're expanding our data set, like, what does that mean exactly in terms of privacy and security?
Yeah, so we've learned a lot since we started collecting this kind of data. The first data was in more clinical settings, so it's very, everything was, not that everything hasn't been spelled out the entire time, but I think we've certain clinicians know how to describe these through their patient advocates as part of their studies. So our initial studies kind of gave us some early feedback about patients who really didn't want to participate in this because we were just collecting data that was really much too invasive for them. For students, it's a little bit different. Part of it is, while we didn't pay them a lot of money, it was enough to say, hey, I'll give you all this data, because they didn't really understand what they were giving up. I think as we were very upfront with them. We are collecting social media data. We are collecting information about your texts and your phone calls. We're collecting the data about where you go, how you sleep, where you sleep, all of that information. People are clearly more savvy as, various reports come out about data privacy leaks. The thing that I keep trying to, it's like I don't try to sell the studies too much, but when I do talk about the studies to try and recruit people, I do tell them that, the goal right now is to collect as much as possible, because we don't know where the signals lie. Mm-hmm. We don't know, I was surprised to see emojis as being an important factor in telling whether somebody's drinking or not. And maybe in hindsight it makes sense, but if I showed you the actual curve, the curve would still be surprising to you in terms of how it has an impact. Turns out that those that use emojis, when you're drinking, your use of emojis increase, but then when you binge drink, your use of emojis decrease. So after the fact, I can describe it, but I wouldn't have understood that was a useful signal. So the goal is collect as much as possible now, understand where the signals are so that we can minimize what data is being collected, and then to have everything that is running to run only on your phone or the data collection device. So it never goes anywhere. Obviously, clear security issues with that, right, because none of our phones are secure. But that's the goal. And I'm still hoping that the promise of the impact we can have is enough to overcome some of these concerns. But first, I don't run my own software on my phone. Right. I don't want to know some of this information. So I fully respect that there are some serious considerations that have to be taken here.
Right. Thank you. So we have another couple of questions. So from Heather Zhang, who's a professor here, she asks, as each smart device collects more data on routines, can this knowledge be used to adapt the device behaviors and capabilities? And what would be the significant roadblock against such adaptation?
Yeah, so I absolutely think that's the case. I mean, I've been reading, and this is old news by now, but I've been reading a lot of articles trying to get at the details of how all of our cloud providers use artificial intelligence about the loads on their machines to impact how they cool the spaces down, so that they can do it closer to net energy zero in those spaces. And I fully believe that the devices we use, already I know my smartphone adapts to the way I use it. It's very different than the way my daughter uses her Android phone. My smart speaker has adapted to me and interacts differently with me than it does the rest of my family. I think that there are some real opportunities here for us to do much more than these sort of trivial interaction based augmentations, but really in terms of making suggestions and recommendations, but particularly in interventions in health, with the health behaviors, particularly when they're risky. The second part of that, what's the most significant roadblock? I think it's in doing that translation from understanding what your routine is to being able to say, aha, this is, therefore I'm going to suggest this is your intervention. So a simple case that we're looking at is in sleep hygiene, where we have 15 recommendations from the sleep hygiene experts. And, we narrow those down right away because maybe you don't drink coffee, maybe you don't drink alcohol. So we can get rid of some of them that are not relevant to you. But then we're trying to use your routine behavior over time to say, which of these 13 interventions should we be providing you at this point in the day for the rest of the day? And it's non-trivial. I don't know how to describe it other than to say it's just really non-trivial to say how to pull out the important routines to say which intervention to pick. And that's in a fairly small set of interventions.
Right. Great. Thank you. So we have many more questions. So from Yuji Tao, Yuji asks, for mental health sensing, what limitation do you see from mobile phone data? And have you thought about data from wearables, sensors on the body, which may provide you with physiological data that could be more indicative of the person's actual status?
Yes. I think I was really biased by the fact that all of those devices tend to be super expensive and not really widespread when we first started this. Now, lots of people still wear Fitbits. Apple Watches are pretty widespread, although not still fairly low penetration. So part of this was looking at how can we collect large, and I'm not here, with our student study, we've collected data from maybe 1,000 students, adding up the 7 years of data. No, maybe about 1,500 students, about 200 per cohort. And so we're still not talking about large sample sizes. And if I had to buy 1,500 Apple Watches or 1,500 devices to give to everybody, that's still really challenging from how do I pay for the student time, the research time, as well as the deployment. So we really relied on things that we just assumed people would have available. Early on in this work, we were buying people mobile phones and buying them phone plans and giving those to them. And fortunately, we don't have to do that anymore. I think maybe we should get back. I mean, your point is absolutely correct in that there are many signals that are available on the new Apple Watch and some of the new Garmin devices that I would love to have, but I just don't know how to get them to enough people to make it worthwhile.
So we'll provide you the participant list after this call, and you'll be sending us all an Apple Watch.
Wonderful.
Okay, so the next question is from Nick Beamster, who's also a faculty here. He's asking, is your work more concerned with discovering relationships, a la statistics, like people who have a certain type of routine are more likely to take their medicine, ML prediction, you slept funny, therefore maybe you missed your medication, or both?
It's really both, because I think both have a lot of value in the healthcare world, just as you've described it. I would love to be able to. So what we're working on in depression is saying, what we're working on is I try to identify essentially best practices. So what are the set of routines that people who have had low depression, as measured by the end of this quarter, how do their practices different from those who have high levels of depression, and how do those change over the quarter? Because obviously they change. And so if I can identify things that make something more indicative of one group or the other, then I can say, for the things that you can control, maybe there are opportunities to move someone from a poor performing group to a higher performing group for whatever performance metric you care about. Right. But also looking at that predictive ability, knowing that someone does something means that they're more likely or less likely to do something in the future, also is really useful from a health perspective. So I think the answer is really both. But maybe we should be more focused so that we can make better progress on one of these two.
Sounds like you have a lot to do. So continuing with the questions here. So we have Sunny Manduva, who's an HCI grad student and a UX researcher. And they ask, it's very insightful and a great keynote. So how do you ensure the sustained reporting that has to be done by the participants over the long duration of the study in these experience sampling methodology studies, all of these studies are related to health? So basically about the self-reporting. Yes,
I mean, that's a fantastic question. It's one we struggle with constantly. My wife actually had a PhD student who looked at the likelihood that people were going to answer particular questions after you rolled out a study, and then the value that they provided to a machine learning algorithm so that you could figure out which ones were the high signal ones. But again, that requires a whole study of the ESM, the EMA study itself before you can do that. We pay people not ridiculously well, but we pay people well to help keep them engaged. We have a huge body of undergraduate students that are on the phone with our participants saying, hey, you're a little low on your participation. We want to make sure you get your full payment. Can you try and answer these questions? But one of the biggest challenges in this kind of work is getting reliable ground truth. We worry about asking questions too often, not just from a compliance standpoint, but some of our instruments really are only meant to be asked once a month. And if you start asking it more often, they become unreliable. But also from a burden standpoint, it's a huge issue that we face, and I'm sure in many of your studies you face too. I think the best suggestion I can give of what we've done that's successful is to have people that are completely in charge of managing compliance on your team that are willing to make those phone calls every single day.
Wow. Yeah, I had not thought of that, but that's really good to know about how you have people actually reaching out to participants constantly to making sure.
And I think this is pretty common in the in clinical trials and clinical studies. We don't do that in HCI. I don't know why. But it is very common there. And so we just stole the idea from them. I can't take any credit for that idea.
Okay, well, thanks for giving us all that idea. So moving on to the next question from Stu Zhang, who's actually a student at Stanford visiting us today. And he says, or he or she says, thanks for the great talk. Based on the book about everything we touch, you mentioned that we're mostly interacting with everyday objects rather than technical ones. But in your second and third examples, we're still sensing through mobile phones or similar technological artifacts. And I'm wondering, what is the obstacle to your vision that you shared at the beginning?
I don't think that there's a technical, technical challenge that we're facing here. I think it's a financial challenge. The amount of added cost I would have to, you can buy a smart water bottle, right? But mine is not smart. It's dumb. I pour water in and I drink it and it doesn't sense how much I'm drinking. But when I looked at the cost of a smart water bottle, I said, well, I'm not going to spend $100 for a water bottle when I can buy this for $30. So, I'm looking around my environment and, I see pens and I see books and I see my exercise machine and I see pillows and I just see all the things that I'm interacting with throughout my work day in my office here. And we'd have to add, a processor to each one. We'd have to add some kind of networking, whether it's a Bluetooth or whether we'd add Wi-Fi, but we have to add that ability for them to sense, to do have some kind of intelligence and then to communicate that information off. And it's not a technical challenge. I really don't think so. I mean, there's IP space and how many devices can we have, but with IPv6, maybe that's less of an issue. And particularly within my home, I'm not concerned about that. If I had my own IP space here, but it really is the cost that I would have to, the amount of money I'd have to spend to get everything I have, or to buy new things that were technically enhanced. That would be a challenge.
Right. So resource constraints.
Yes.
So from Solomon Dworkin, they ask, have you thought about the routines of groups versus routines of individuals and how they interact with one another?
That's a lovely question, Solomon. Yes, but not to any great degree. There's still so many challenges we're facing on the individuals, and I'll be very honest. We're really torn between whether the right approach is to look at from a machine learning standpoint to create these population models that can represent an entire group, or to build personalized models, or to start with population models and then move to personalized models. We've tended to opt for personalized models because we think naively. We think that some of these routines, like how I heavy drink is going to be different than how you heavy drink, and it's going to manifest itself differently. Our cohort sizes are too small to really know differently than that. So we're hoping that once you get to this larger NIH trial, once that launches, we'll be able to understand that better. With the depression work, we are absolutely looking at these groups as large groups and trying to identify with these rules, this association rule mining approach, can we identify rules that describe or define the behavior of people who are more significantly depressed from those that are less significantly depressed? But it's way too early for me to say anything intelligent about the viability of either of those approaches. I imagine it's very domain specific, but I absolutely agree that we have to be looking at both, that you can't look at these independently.
Right. That's a great answer. So I think we're almost at the end, but I'd like to ask just one final question. So you did allude to this a little bit in your talk, like many of the examples you gave are sort of assuming that people are moving around a lot more. So have you thought a bit more about how your models would have to change given the current conditions of the pandemic?
Yeah. One of my students, I feel he's had a tough time because he was doing this sleep work And he did take into account, he had people wear a Fitbit, and he had people, he was looking at two different things. He was looking at, can you detect when someone is receptive for a mobile intervention? And then based on when he triggered that, when he detected someone was receptive at that moment, he tried to figure out what was the right intervention to provide for the sleep work. So he's faced two significant challenges. One is people's sleep patterns have changed dramatically in COVID times, particularly for students. Right. It's shifted and gotten longer in cases, but for some it's gotten shorter. It's kind of a lot more noise in the data that he's seeing for very similar cohorts, just 1 year to the next. And the second challenge he's seeing is that times of motion. So if we're sedentary while, and then we start moving, that was a really good signal to his system that would predict someone's receptive, his receptivity detector. And basically the receptivity detector is completely just failed, right? So in this intervention, in the second intervention that he ran over this past spring, he said, when the receptivity detector just didn't trigger. It just didn't trigger at all. And so we didn't get to intervene and anywhere near as many, as often as we had in the first year of the study. So I still believe there are important signals there about how we can be receptive to our interruptibility. But whether they can be detected, now I spend most of my day in front of a computer and not so much interacting with my phone. So maybe it's more instrumentation of my computer or desktop that I have to worry about. But there, it just needs to, it needs to be different. We need to train all new models for a pandemic. God forbid we ever have to face this again. Great.
So there's one final question here that just came in. I think we'll finish off on this question, which is also from Sunny Manduva, who said that, as someone who's focused on design for imperfect ML systems, may I ask how you address the ethical conundrums of how your work could be used? So since habit, tech usage, and health are your research focus.
Yeah, I mean, you have some really good questions, Sunny.
And now we need another hour to answer the ethical questions.
I will try and answer this very quickly in that I don't have great answers on how the technology I'm developing can be used. I will only say that I have really tried very hard to focus on problems that I think will benefit, with no ounce of hubris in this, really work on problems that will help people. Looking at their substance abuse, looking at their mental health, looking at their ability to remain independent. My focus has been very strictly on kinds of problems that I think if we solve them can actually help individuals. But I have no doubt that you could take my routine behavior analysis work and apply it to all sorts of, you could sell me stuff I don't want. I mean, that I do want, but I probably shouldn't have. You could apply it to all sorts of things that would just be horrific. And I don't have any great answer on the ethics side. I'm sorry.
Great. Well, I think that's a great way to end. Aside from you giving us all the Apple Watches, we'll be looking forward to that. But thank you so much, Anind, for visiting with us today at UChicago CS. And we look forward to keeping in touch with you. And thanks again. So I guess I'm the only one that you can hear clapping.
Thank you all for coming out. I appreciate it.
Okay, great. Thank you so much, Anind.
All right.
Bye.